Today, I'm going to discuss with you some basic information that will be helpful if you want to take advantage of open source utilities for the Linux operating system to perform some digital forensics. One of the popular tasks that you might be confronted with is the recovery of data from a erased or corrupted USB stick. So here is one, and we're going to look at it under Windows first, and then under Linux, and then talk about some of the tools. So let me insert the disk, and we'll see that the folder looks empty to Windows. We have it labeled as Store and Go. Let's look it over here. So on your bottom left, you see the D drive, and the folder is empty. Let's switch our view over here to our VirtualBox version of Linux. Happen to be using Linux Mint Rosa 17.3. Other Linux distributions should work fine as well. So I've opened the terminal. So I have the command line interface in front of me, and I will look for a minute. First, let's open the GUI, and we will see that, well, we actually don't see anything but our C drive. And if I type mount-L, I will see that there is an ext4 file system that is mounted on root, and that is labeled /dev/SDA1. So let's look over in that DEV directory, and let's look at everything that matches SD. And we can see that we have logical partitions. Looks like there are 3, SDA1, SDA2, SDA5, that are on that first disk, which happens to be my virtualized hard disk. So I will want to, inside of Mint here, look up in the Devices menu and go down to USB and attach that USB disk. Now, we see that we have that drive. It's viewable. There's some system volume information by default, but there is no other data, no viewable files on this USB stick or pin drive. Return to my terminal, and how about let's look at that dev directory again, and we see, oh, some new things have shown up in that directory. SDB, another file system. So let's go back and issue this mount command again, which lists things that are mounted on my file system. And I can see that there is on /dev SDB1 some media under my username, which I am logged in as NOS120, and it's store and go. That seems to match what I've seen in the graphical user interface as it relates to my USB stick. We'll take a look at a command that is available on my Linux operating system called dmesg, D-M-E-S-G, and we can see using the man system on Linux that this dmesg command prints the kernel ring buffer. The kernel ring buffer is a sort of a rolling log list of things that are going on in your system. So we're basically going to use that command and look for, so using the grep command, anything related to this new file system that we've discovered. And we can see by looking at the ring buffer that the SDB was an attached SCSI removable disk. And it just so happens that on Linux, this version in particular, that all disks use that SCSI drivers, whether they're SATA, IDE, or legitimately SCSI drives. So this is not a surprise to me. The next thing that we want to look at are some tools that are available to us for doing the digital forensics. Okay? So we already looked at the mount command. So mount allows us to mount or unmount a file system, but also just used in its simple form, mount will show us the file systems on a device. So we basically just used mount in that format. You can look at it right here. Both of the options are just that, optional. We can see that from the square brackets, and it lists all the mounted file systems of a given type. And since we didn't even specify the type, we just saw all the file systems that are on our virtualized Linux, including both the hard drive SDA1 and this new USB stick on SDB1. Also, in addition to mount, we used grep, and we saw that grep under Linux allows us to look for lines that match a certain pattern and then basically carve those out to display on the standard out, which by default is the screen. There's also a command stat, and we can look at the man page for stat, and that displays file or file system status, particularly some metadata about a file. So that may be useful to us when we are doing some analysis. Also, there is a command called dcfldd. If you try to open the man page on your system, you may or may not see the man page. dcfldd happens to be a tool that I had to manually install. I'm going to show you how to do that in just a minute. But right now, just look at dcfldd and understand that it is an enhanced version of a disk tool. And we can see that it is mainly used for forensics and security. We're going to use dcfldd to make a copy of our USB drive bit by bit. So we're not going to copy files like the Linux cp command, but we're going to make a bit by bit copy of the file system so that we can analyze it. There's also of use to us the SHA-1 for computing a message digest or a hash. This is useful for determining the integrity of one file as associated to another. So you may have used a hash function when you download software from a website. The vendor often publishes the hash, and then after you download, you can use a hash calculator to recalculate it so that you're sure that those two files are identical and no corruption occurred after the transfer. So having that at our disposal will be important. And then there is strings, and strings is a tool that will print viewable characters in a file. So we can see that for each file passed to strings, that this tool prints any printable character sequences that are at least 4 characters in length. Now, why would this be useful? Well, in some cases, we are presented with files or portions of data that might be in a binary format with characters that are unintelligible to a human, but somewhere embedded in those files might be some short snippets of readable characters that might give us some clues as to what that file is all about. What maybe, is it a PDF file? Is it an Excel spreadsheet? And at least if we have some of those clues, we may be able to dig deeper using another technique. And lastly, we will be using 2 open source tools for recovery, one called PhotoRec, and Foremost. PhotoRec happens to be part of a package called Test Disk. So what you will want to do, if you do not already have the dcfldd tool, you will want to install it using the package manager. And I'm on an Ubuntu dialect, Linux Mint, so I'm going to use sudo apt-get install dcfldd is the package name. I've already installed this package, so I'll probably get a message telling me that it's already installed. Because I use account elevation with sudo, I have to put in my account password, and it's actually going to go through again, but we could see that nothing's upgraded and nothing's newly installed because I had already installed this package. You will see a little bit different. Then we want to use the package manager to install Foremost. And then lastly, we will also use the package manager to install a package called Test Disk, which again is the package that contains a tool called PhotoRec. All right, so at this point, we are about ready to be able to do some analysis on our USB and actually recover some viewable data from that disk. So stay tuned for the next installment.